Next problem on complex number. By considering the expression of cos theta plus I sin theta raised to 3 in two different ways. Find the expression for sin 3 theta and cos 3 theta in powers of sin theta and cos theta respectively. So this example gives the procedure of answer of this example. That is, we have to consider the expansion of this cos theta plus I sin theta raised to n in raised to 3 in two different ways. So first is what? By using De Moivre's theorem. What we have? Cos theta plus I sin theta raised to 3 is what? Cos 3 theta plus I sin 3 theta. This is by using De Moivre's theorem and by using binomial theorem. So what is the binomial theorem? X, this is suppose x, this is suppose y, then x plus y cube is what? X cube plus 3xy square plus 3 plus 3 x square y plus 3 plus y cube. So this is the expansion, that x plus y cube is what? X cube plus 3xy square plus 3x square y plus y cube. So we have the four terms, and this is by using binomial theorem. That is, we can find the power of any integer power of a natural power of x plus y. X plus y raised to n is what? By using binomial theorem, it is nc0 x raised to n plus nc1 x raised to n minus 1 y. In this way, all the remaining terms. So this is binomial theorem, and this is by using binomial theorem. So we consider, we find the expansion of here of cos theta plus I sin theta raised to 3 by using De Moivre's theorem. This is cos 3 theta plus I sin 3 theta, and here by using the binomial theorem. So cos theta plus I sin theta raised to 3 is what? Cos cube theta plus this 3 cos square theta I sin theta, okay. So 3 this square of this into this, okay, plus next term is plus, actually plus cos theta into I square sin square theta. So what is I square? I square is minus 1, that's why this term is minus 1. So right here plus, so first plus, and then write this step, that plus 3 cos square theta, not cos square theta, plus 3 cos theta I square sin square theta, and then write I square as minus 1. Therefore we have this term minus 3 cos theta sin square theta, and the last term is I cube plus I cube sin cube theta. And what is I cube? Is I square into I, and I square is what? Minus 1. So we have minus I sin cube theta, okay. So we have this term, right? In the next step here, write plus, first write plus I cube sin cube theta, and then write as I cube as minus I, because I cube is what? I square into I, and I square is minus 1. So we have this is the expansion of this cos theta plus I sin theta raised to 3 by using binomial theorem. Then collect the imaginary parts and real part, that is free from I, is called real part, that is cos cube theta minus 3 cos theta sin square theta in one bracket, plus take I common from these two steps, that is we have 3 cos square theta minus sin cube theta. This is the imaginary part and this is the real part. So this is in the x plus iy form, okay. And then compare LHS and compare the RHS of this equation number 1 and 2. What do we have? Cos 3 theta plus I sin theta. LHS are same, therefore RHS are same. So what do we have? Cos 3 theta plus I sin 3 theta is equal to this term. And then compare the imaginary part and real part. So real part in the LHS is cos 3 theta, and in RHS the imaginary real part is this bracket. So write this, and then its simplification. Its simplification is what? Cos cube theta 3. Write this sin square theta is 1 minus cos square theta, and then for we have answer 4 cos cube theta minus 3 cos theta. Why this is simplification? Because here the question is find the expression for sin 3 theta and cos 3 theta in powers of sin theta and cos theta respectively. That is, we have to find the expansion of sin 3 theta in terms of sin theta, and we have to find the expansion of cos 3 theta in powers of cos theta. So we substitute the sin in terms of cos, is here sine square. We substitute in terms of cos, that is 1 minus cos square theta. And so this is the expression for cos 3 theta in the power of cos theta. Then compare the imaginary part, that is in the LHS, the coefficient of sine I is sine 3 theta. In RHS, 3 cos square theta sine theta minus sine cube theta. And then write this cos square theta in terms of sine theta. That is cos square theta is 1 minus sine square theta, and we have this answer. So this is the expansion of sine 3 theta in terms of powers of sine theta. So find the expression for this is the final answer. Okay, so this example, this sentence that by considering the expansion of this cos theta plus I sin theta raised to 3 in 2 different ways, we have to find this expression for sine 3 theta and cos 3 theta. The next problem is of the same type. Here is we have to prove cos 3 theta as this, that is cos cube theta minus. So this is the final answer. Up to this, solve this. No need to write sine square theta as 1 minus cos square theta. So same question, same answer. So okay, so we have to prove sine theta as 3 cos square theta sine theta minus sine cube theta. Okay, so the same question, so same proof, that is by considering 2 ways the expansion, we have this answer. The next problem is cos 6 theta and sine 6 theta, similar to this problem. That is, consider expand this cos theta plus I sin theta raised to 6 in 2 different ways. For this problem, find cos theta plus I sin theta raised to 6 in 2 different ways. We have the expression for cos 6 theta and sin 6 theta. So cos theta plus I sin theta raised to 6 is by using binomial theorem. What do we have? It is we have the total 7 terms. Okay, what are that terms? These are the terms. That 6 power of this. Next term is what? What is first? Write x plus y raised to 6. So x plus y raised to 6 is what? First term is x raised to 6. NC 6C0 x raised to 6. 6C0 is what? Then next term is plus 6C1 x raised to 5 x raised to 5. 6C1 is 6 and x raised to 5 means cos raised to 5 into y I sin theta, that is I sin theta, right here I sin theta. Next term, this is right here I sin theta. Okay, right here I. So next term is what? We have total 6 terms in this expansion. So what is the first term? X raised to 6, that is cos raised to 6 theta. Then next term is 6C0, 6C1 is 6. And then its 5th power, cos raised to 5 theta. Its first power, I sin theta. So right here, I. Next term is plus 6C2. 6C2 is by using calculator, we find 62, it is 15. Then its 4th power, cos raised to 4 theta. So power of cos, first term is 6, then 5, then 4, cos raised to 4 theta. Plus its square. Okay, so here is I sin theta, here is I square sin square theta, or I sin theta in bracket square. Then plus next term is what? 6C3. 6C3 is what? 20. By using calculator, 6C3 is 20. Then its power decreased by 1. Here is cos raised to 4 theta, here is cos cube theta. And I sin theta raised to 3. Its power increased by 1. I sin theta raised to 3. Okay. Then next term is 6C4. If you find 6C4 by using calculator, then it is 15. What power of cos theta decreased by 1. Here is cos cube theta. So here is cos square theta. And I sin theta raised to 3 increased by 1. So it's raised to 4. Then plus next term is 6C1. 6C5. 6C5 is what? 6C5 is 6 by using calculator. And the power of cos theta is here 2. Therefore here is 1. And I sin theta raised to 4. Here is raised to 5. And then last term is 6C1. 6C6. 6C6 is 1. And its power is become 0. That is 1. And therefore I sin theta raised to 6. Okay. So we have total 7 terms. This is first term, second term, third term, 4, 5, 6, and 7. So This is the expansion of this x plus y raised to 6 by using binomial theorem. Okay. So we have the answer cos raised to 6 theta. If you search binomial theorem on Google, we have the expansion of all these brackets. So cos raised to 6 theta minus 15, 15 is minus 15, this term minus 15 cos raised to 4 theta. I square is minus 1, that's why here is the minus sign, sine square theta. And then this term plus 15 cos square theta. I raised to 4 is plus 1, because I raised to 4 means I square into I square. That is plus 1 sine raised to 4 theta. Okay. And this term plus term I raised to 6 is what? Minus 1, because I raised to 6 means I square into I square into I square. Minus 1 into minus 1 into minus 1 is minus 1. So that term is minus sine raised to 6 theta. So all these are real part that is free from I, and then the terms containing I, this term 6 cos cube cos raised to 5 theta sine theta. Right here I, correction is I. Take that I common. Here write I. Here write I outside the bracket. Then in bracket 6 cos raised to 5 theta. This term. Then this term, because I cube means what? I square into I is minus term, minus 20 cos cube theta sine raised to 3 theta minus cos cube minus 20 cos cube theta sine cube theta. Okay. And then this is the term. Okay. So here is I raised to 5 means I square into I means minus 1 into I, that is plus I. So is what? Minus plus 6 cos theta sine raised to 5 theta. Okay. So these are the coefficients of I. So here write I. And the cos theta plus I sine theta raised to 6 by using binomial by using De Moivre's theorem is what? Cos 6 theta plus I sine 6 theta. And then compare the RHS of these equations. This is the RHS of this equation. And the value of cos theta plus I sine theta raised to 6 is this. So compare these two. What we have? Compare real and imaginary parts. So cos 6 theta is what? Is this bracket, first bracket. Cos raised to 6 theta minus 15 cos raised to 4 theta sine square theta plus 15 cos square theta sine raised to 4 theta minus sine raised to 6 theta. And sine theta is what? That is the coefficient of I sine 6 theta is this bracket. Okay. So we have this. Okay. So this is the this is we have to prove. Okay. So all these problems, this cos 3 theta sine 3 theta expansion of, and the expansion of cos 6 theta and sine 6 theta methods are set. So these are some different problems. So if there is problem of expansion of cos, suppose cos 5 theta and sine 5 theta, then find the expansion of cos theta plus I sine theta raised to 5 in two different ways and find the answer. Or if the problem is cos 4 theta and sine 4 theta, then expands cos theta plus I sine theta raised to 4 in two different ways, that is by using binomial theorem and De Moivre's theorem, and find the expression for cos 4 theta and sine 4 theta. So these are the two sample problems. Sine 6 theta, this is the sine 6 theta and cos 6 theta. Okay. Next problem is find the expression for cos raised to 5 theta sine raised to 5 theta in terms of cosine and sine of multiples of theta. That is sine 3 theta, sine 4 theta, sine 5 theta, cos 4 theta, cos 2 theta. Okay, multiple of theta means theta, 2 theta, 3 theta, 4 theta. So this is the different problem. Here is if the problem is prove that cos 5 theta and sine 5 theta, then It is the answer is what? Expand cos theta plus I sin theta raised to 5 in two different ways and solve the problem. But here is it is not a cos 5 theta or sin 5 theta. It is cos raised to 5 theta and sin raised to 5 theta. That is, this problem is different than the previous two problems. This problem is different than the previous two problems. So what is the method? Here is the power. It is not cos 5 theta. It is cos raised to 5 theta. It is not sin 5 theta. It is sin raised to 5 theta. So what is the method? We have to expand this. We have to find the expression for this too. Okay. So z, suppose z is cos theta plus I sin theta, and then by De Moivre's theorem, suppose k is integer, then z raised to k is what? Cos k theta plus I sin k theta. That is z raised to k means cos theta plus I sin theta raised to k is what? Is cos k theta plus I sin k theta by using De Moivre's theorem, and z raised to minus k is what? Cos minus k theta, but cos minus theta is cos theta, plus I sin minus k theta, and sin minus k theta is minus I minus sin theta, sin k theta. Okay, so z raised to minus k is what? Suppose this bracket raised to minus k is cos minus k theta plus I sin minus k theta, and cos minus k theta is cos k theta only, because cos minus theta is cos theta, and sin minus k theta is minus sin k theta, because sin minus theta is minus sin theta, and then their addition is what? 2 times cos k theta, because plus I sin k theta and minus I sin k theta becomes 0, and this cos k theta plus cos k theta 2 cos k theta, and z raised to k minus z raised to minus k is what? Their subtraction is this becomes 0, and this becomes 2 times I sin k theta, 2 times I sin k theta. Okay, and z raised to minus k means 1 by z raised to k, right? Here z raised to minus k as 1 by z raised to z raised to k, 1 by z raised to k. And so if we substitute k as 1, then what we have? Z plus z raised to minus 1 means 1 by z is equal to 2 cos theta. Okay, similarly z square, if we substitute k as 2, then we have z square plus 1 by z square, z raised to minus 2 means 1 by z square is 2 cos 2 theta. In this way, if we substitute k as 3, then we have z raised to 3 plus z raised to minus 3 is what? 2 times cos 3 theta in this way. Okay, then take the fifth power of both sides of this equation, z plus 1 by z raised to 5 is equal to 2 raised to 5 cos raised to 5 theta, because the problem is find the expression for cos raised to 5 theta, sin raised to 5 theta. That's why we take the fifth power of both sides. Okay, otherwise, and in order to prove the sin raised to 5 theta expression for sin raised to 5 theta, we expand, we take the fifth power of this equation. Okay, so we have to find the expression for cos raised to 5 theta. So we take the fifth power of both sides of this equation. If the question is find the expression for cos raised to 6 theta, then take the sixth power. If the question is find the expression for cos raised to 7 theta, then take the seventh power in this way. Okay, so we see the another problem for cos raised to 6 theta, cos raised to 7 theta in next problem. So z plus 1 by z raised to 5 is 2 raised to 5. Right here 2 raised to 5 as 32, or the remain as it is 2 raised to 5 cos raised to 5 theta. Okay, so expand this z plus 1 by z. So change the sides. Write this in LHS as 2 raised to 5 cos raised to 5 theta as LHS, and z plus 1 by z raised to 5 by using binomial theorem. The x plus y raised to 5. We have 6 terms. So first term is z raised to 5, z raised to 5. Then next term is what? 5c1 is 5, z raised to 4, 1 by z, z raised to 4, 1 by z, that is z cube. Then next term is what? 5c2, 5c2 is 10, and then z raised to 3 and 1 by z square. So z raised to 3 into 1 by z square is what? Is z. Right in the next step as z. Then next term is 5c3 is again 10, z raised to 2, 1 by z cube is 1 by z. This 10, 1 by z. Next term is 5C4 answer is 5C4 by using calculator answer is 5. Z into 1 by Z raised to 4, that is 1 by Z cube, this 1 by Z cube, and last term is what, 5C5, that is 1 by Z raised to 5. So this is by using binomial theorem expansion. We have total 6 terms, 1, 2, 3, 4, 5 and 6 terms. Okay, then write the first and last term in one bracket, take 5 common from the second and second last term, and then take 10 as common from these two terms. We have this, and the value of this bracket is what? If you substitute k as 5, then we have Z raised to 5 plus 1, Z raised to minus 5 means 1 by Z raised to 5 is 2 cos 5 theta. So write the value as 2 cos 5 theta of this bracket, plus 5, this value is 2 cos 3 theta, and this is 2 cos theta. Okay, so we have this answer. Okay, so cos raised to 5 is what? Then 1 by 16, 2 raised to 5. 2 raised to 5 is actually 32, but take this 2 as common. 2 in bracket, what we have? 2 by 32 is 1 by 16, cos 5 theta plus 5 cos 3 theta plus 10 cos theta. Okay, because 2 is common from this side, and then shift this 2 raised to 5, that is 32 on RHS. Then 2 by 32 is 1 by 16. So this is the answer of this problem, that is the expression for cos raised to 5 theta. Now we have to find the expression for sin raised to 5 theta. So take the fifth power of this equation. What is this equation? Z raised to k minus 1 by Z raised to k is equal to bracket raised to 5. Bracket raised to 5. So this equation. Okay. From this, substitute k as 1. What we have? Z minus 1 by Z. Z minus 1 by Z is 2i sin theta. 2i sin theta. If we substitute k as 2, then we have Z raised to 2 minus Z raised to minus 2 means 1 by Z square is 2i cos sin 2 theta. In this way, we can write also Z cube minus 1 by Z cube is 2i sin 3 theta in this way. Okay, then take the fifth power of this equation. Z minus 1 by Z raised to 5 is 2i sin 5 sin theta bracket raised to 5, and then this 2 raised to 5, that is 32, and I raised to 5 is what? I raised to 5 is I square into I square into I, and I square into I square is plus 1, and that is I raised to 5 is I sin raised to 5 theta is equal to Z minus 1 by Z raised to 5, and the expansion is the same. This expansion only, right? First term plus, then second term minus, then plus minus plus minus. Okay, so only the here is Z minus 1 by Z, and here is this is the expansion of Z plus 1 by Z raised to 5. So just write first term plus, then minus, plus, minus, then plus and minus. Okay, and then collect the terms in the bracket, first and last in one bracket, then second and second last, take minus 5 as common, so Z cube minus 1 by Z cube, and then take 10 plus 10 as a common factor, so Z minus 1 by Z, and then substitute Z raised to 5 minus 1 by Z raised to 5 is 2i sin 5 theta. Similarly, this is 2i sin 3 theta, and this is 2i sin theta. Okay, and then we have 2 raised to 5 I sin 5 theta is this. Okay, so take I common from RHS and also 2 common from RHS, and shift this 2 raised to 5 I in RHS. Okay, so it is become 2i divided by 32i. I get cancelled 1, and 2 by 32 is 6, 1 by 69. We have this. So this is the important problem for exam. So what are the problem? What is the problem? Find the expression for cos raised to 5 theta and sin raised to 5 theta. If the problem is for expression for sin raised to 6 theta and cos raised to 6 theta, then same procedure, only take 6 power of both sides. Okay. If the problem is for cos raised to 7 theta and sin raised to 7 theta, then take 7 power of both sides. So next problem is for cos raised to 6 theta and sin raised to 6 theta. All the procedure is same. Just write take the 6 power of both sides. So Z plus 1 by Z raised to 6. The expansion by using binomial theorem. We have 6 terms. What are that? 6C0. That is the value 6C0 is 1. Then 6C1, 62, 6C3, 6C4, 6C5 and 6C6. So the values of 6C1 is what? 6. 6C2 is 15. 6C3 is 20 by using calculator. Then in this way 6C4, 6C5, 6C6. And the power of z becomes start from z raised to 6, then z raised to 5, z raised to 4, z raised to 3, z raised to z, and then z raised to 0. And the power of 1 by z becomes start from 1 by z raised to 0, that is 1, 1 by z raised to 1, 1 by z raised to 2, 1 by z raised to 3, 1 by z raised to 4, 1 by z raised to 5, and 1 by z raised to 6. That is, we have total 7 terms. The expansion of this bracket raised to 6, therefore we have 7 terms. If the power is 7, then we have 8 terms. So these are the terms. Collect the terms of first and last, first, second, and second last in this way. The middle two, okay, and the middle term 20 as it is. And the value of z raised to 6, 1 by z raised to 6, by using this substitute k as 6, we have 2 cos 6 theta. In this way, the value of this bracket, and therefore we have this expression for cos raised to 6 theta. Similarly, we have to find the expression for sin raised to 6 theta. Then take substitute k here 1, 2, 3, and then take 6 power of both sides. Okay, and so what is z minus 1 by z raised to 6? This I raised to 6 is what? I square into I square. That is minus 1 into minus 1 into minus 1 3 times. That is minus sin 2 raised to 6 sin raised to 6 theta. And then expression is what? Plus term, plus minus in this way. We have this expression and substitute the values. So this is cos raised to 7 theta and sin raised to 7 theta. That is take the 7th power of both sides. So same type example, 7th power. This is the 8 sin raised to cos raised to 8 theta and sin raised to 8 theta. That is what? The same procedure, only take z plus 1 by z raised to 8. We have total 9 terms. What are that? 8c0, 8c1, 8c2, 8c3, 8c4. This is by using calculator. And then z raised to 8. First term is z raised to 8, z raised to 7, z raised to 6, z raised to 5, z raised to 4, z raised to 3, z square, z, and then the 1 by z starting from 0 power. Then 1, 2, 3, 4, 5, 6, 7, 8. We have, and then collect the terms, first and last, second and second last, and all these terms, and substitute the values of this bracket. Similarly, the second equation, 1 by z, z minus 1 by z is 2i sin theta. Take 8th power, and we have this term plus minus. Only change is what? Plus minus term. Show that this cos 3 theta plus I sin theta raised to 5. It's 2 mark example. So we have to show this. So this is by using binomial theorem. What do we have? Cos 3 theta plus I sin 3 theta is cos theta plus I sin theta raised to 3. So 3 into 5 becomes 50. And this is cos theta minus I sin theta raised to 3. Then here is also 35. Cos 5 theta plus I sin 5 theta is cos theta plus I sin theta raised to 5 raised to 7 is 35. 7 into 5. And here is cos theta minus I sin cos 2 theta minus I sin 2 theta is cos theta minus I sin theta raised to 2 raised to 5 becomes raised to 10. And this is e raised to I theta raised to 15 by using this is the in the exponential form. Cos theta plus I sin theta is e raised to I theta. This is e raised to minus I theta, cos theta minus I sin theta. Similarly here, and then e raised to I theta divided by e raised to I theta raised to 15 divided by e raised to I theta raised to 35 becomes x raised to m divided by x raised to n is x raised to m minus n. 15 minus 35. Okay, right? E raised to I theta 15 minus 35. What is the answer? Minus 20 answer. Minus 20. E raised to minus I 20 theta, or e raised to minus 20 I theta. And this is e raised to I minus I theta raised to 3 raised to 10 means e raised to minus I theta raised to minus 7. That is e raised to 7 theta, and then minus 20 plus 7 becomes minus 13 I theta. That is my cos 13 theta minus I sin 13 theta by using this is the expansion of this e raised to minus 13 I theta in polar form. This is the problem for sin raised to 8 theta and cos raised to 7 theta. That is mixed problem. So in order to prove find the expression for cos raised to 7 theta, take the 7th power, and in order to find sin raised to 8 theta expansion expression for sin raised to 8 theta, take the 8th power of that second equation, this equation. Okay, so this is the mixed problem. This is the proof for sin raised to 8 theta. This is proof for cos raised to 7 theta. The next problem is prove that minus 1 plus I raised to 7 is minus 8 in bracket 1 plus I. So consider LHS and show RHS. Okay. So LHS is what? Minus 1 plus I raised to 7. So directly by using binomial theorem, we will find the minus 1 plus I raised to 7, x plus y raised to 7. And we have this answer. Or we express this minus 1 plus I in polar form. So what is the polar form? Root 2 cos 3 pi by 4 plus I sin 3 pi by 4 is its polar form. Already, what is the polar form of this minus 1 plus I, 1 plus I, 1 minus I? Already we observe this polar form. So this is the polar form. And then take 7 power. So the bracket, the RH, the bracket raised to 7. Root 7 raised to root 2 raised to 7 is is 2 by 2 raised to 7 by 2. 2 raised to 7 by 2. You can find by using calculator 2 raised to 7 by 2. So actually root 2 raised to 7 means root 2 into root 2 into root 2 7 times. And root 2 into root 2 is 2. So 2 into 2 into 2, that is 6. That is 6 root 2 is the value of root 2 raised to 7. And then this is by using binomial theorem cos theta plus I sin theta. This is De Moivre's theorem. Cos theta plus I sin theta raised to n is what? Cos n theta plus I sin n theta. So this becomes cos 3 pi into 7 by 4 means 21 pi by 4 plus I sin 21 pi by 4. And then value of cos 21 pi by 4 as cos 5 pi by 5 pi plus pi by 4 plus sin 5 pi by 5 pi plus pi by 4. And this is cos 5 pi by 5 pi plus pi by 4 is minus cos pi by 4. And this is minus sin pi by 4. And then value of minus cos pi by 4 is minus 1 by root 2. And the value of sin pi by 4 is 1 by root 2. And then we have answer 2 raised to 3 minus 1 minus I. 2 raised to 7 by 2 means 2 raised to 3 into root 2. Then take this minus sin root 2 as common. So root 2 get cancelled. 2 raised to 3 minus 1 minus I, that is RHS. Express this number in polar form and hence find z raised to 10. So first simplify this number in the form of x plus yi, x plus yi. So where to find simplify this number means rationalize the denominator, because there is division of complex number. 1 minus I root 3 multiply and divided by the same factor, and the multiplication of numerator, multiplication of denominator. 1 x plus y into x minus y, x square minus y square. Answer is 4. So 3 this 6 by 4 means 3 by 2. So minus half is the real part plus root 3 by 2, I is the imaginary part. So find modulus. Modulus is this modulus of 3 is 3, and root its square plus its square. What is modulus? Root x square plus y square is 3. 4 is LCM. So this is 3 answer. Modulus, and argument is what? By using the rule tan inverse y by x. Tan inverse y by x. So we have the modulus is argument is 2 pi by 3. And so the answer is what? 3 cos 2 pi by 3 plus I sin 2 pi by 3. This is the polar form of this number. This is the polar form. Tan inverse y by x by using formula tan inverse minus root 3. Tan inverse minus root 3 is 2 pi by 3, because tan 2 pi by 3 is minus root 3. Okay. So this is the polar form. And then z raised to 10 is what? 3 raised to 10 into this bracket raised to 10. And by using De Moivre's theorem, this bracket is what? Cos 20 pi by 3. 10 into 2 pi by 3 means 20 pi by 3 plus I sin 20 pi by 3. And this 20 pi by 3 as a 6 pi plus 2 pi by 3. And 6 pi means 0. So cos 2 pi by 3 and plus I sin 2 pi by 3. And then cos 2 pi by 3 is minus 1 by root 2. Sin 2 pi by 3 is root 3 by 2. So this is the answer. Z 10 raised to z. Z raised to 10. This is z raised to 10. So these are some problems for exercise. Solve all these problems. This is the problems of the first type. This is the problem of the second type, that is its power. Here is cos 4 theta, sin 7 theta. Here is the power, cos raised to 5 theta, sin raised to 5 theta. So there are two different methods. This is also the problems of the same this type. This cos 4 theta means the problem of this type. Solving this equation. So these are the problems of previous lectures. Find the expression for cos 7 theta and cos sin 7 theta. So this is the problem of the on the Devon's theorem. Already this problem solved by the method. These are the answers of the problems. So solve. This is the exercise number 2. Solve all these problems, and the answers are given here. So here the chapter complex numbers over, and all the syllabus of paper number 1, that is algebra, of all the syllabus of first terms over at this lecture, over this lecture, because there are 3 topics. First is relation and sets and relation. The second topic is what? Integers, and the third topic is complex numbers. So all the syllabus of paper first over here. So solve all these exercise in the assignment notebook, assignment separate notebook, all the exercise of chapter number 1, 2, 3, and the internal marks are given through this exercise assignment notebook. So we'll stop here.